So we have a question subarray sum equals k. So it means that given an array of integers nums and integer k, we have to return the total number of subarrays whose sum is equal to k, right? So how many subarrays there are present whose sum is equal to k? We have to count. We need to give back the count. So over here we see that a subarray is a continuous non-empty sequence of elements within an array. So it should be a contiguous. It should be non-empty and sequence of elements within any array. So over here, if you see that k is equal to 2, the sum should be 2. So how many subarrays are here? So it is 1, 1, these both ones, and then finally these both ones. So there are 2, right? The count is 2. Then similarly for this, we have k is equal to 3, and the sum should be 3, okay? So we see that 1 plus 2 is also 3. And is there any other subarray wherein the sum is 3? So and also 3 itself is it has only a single element, but that itself is subarray, right? Even though it has only a single element 3 subarray, so we have to take that also in consideration, and hence we have so we return 2 as our count. So how do we do this subarray? We can just see an approach over here. We see that let's just take this array, okay? 3 4 7 2 minus 3 1 4 and 2. Okay, 3 4 7 2 minus 3 1 4 and 2. So we see that our k should be 7. Okay, so the sum should be 7. So when we add 0th index and first index, we get 7. Then that is one subarray where we get 7. Then there's another subarray where we get 7. How? 7 plus 2 minus 3 and plus 1. So minus 3 plus 1 will be minus 2. Minus 2 plus 2 will be 0, and then plus 7, that therefore will be 7. So in the final subarray wherein we get k is equal to 7, that one will be 1 plus 4 plus 2, which is also equal to 7. So we cannot just juggle the digits like that. It has to be like contiguous. So contiguous non-empty sequence of elements. It's called a subarray. And then so sum should be k. That's the most important thing to note. So over here we have to return our output as 3 because there are 3 subarrays wherein we get our sum as 7. So how are we going to group these together, like 3 and 4, and then from which index to which index can we say that our like 7 plus 2 minus 3 plus 1 is actually 7 is actually equal to k? How do we find from which index to which index we get the sum as k, and where to stop and where to start? So all these will be decided from this question. For example, we are starting at 1 over here, and then we are ending at 2, and then we see that the sum is actually equal to 7. And then once we find that the sum of some numbers is equal to 7, that is it could be any number of numbers. Here there are two numbers whose sum is 7. So and then we will increment our count by 1 each time. So our count will be 0 here, then it become 1, then 2 and 3. So our answer will be 3. How can we solve this in a single traversal method? So we are going to use like order of n complex time complexity. So how are we going to do it within one single traversal? We can do that by, we'll just take the same example again, by using a prefix sum array. Okay, there's something called prefix sum array, which means that it means that there are elements over here, right? So first prefix sum array will contain 3. Then we need to add the next elements, and then we have to keep going on. Like 4 plus 3 is equal to 7. Then what you have to do? It should be 7 plus 4 plus 3. That will be, or will that be? Will that be 14? And then 3 plus 4 plus 7 plus 2, that will be 16, right? Then minus 3. So 16 minus 3, what will that be? That will be 13. And then 13, that plus 1 will be 14. Then we have plus 4, that will be 18. And then 20. So it keeps on going like that. That will be a prefix sum array. So we have to calculate this prefix sum array to solve our question. So we'll just keep name our prefix sum array as current sum or cur sum. So how we're going to solve this is by using a hash map basically. So we have to check if the prefix sum is actually equal to k. In this example, we are keeping k as 7. Okay, so the sum should be equal to 7. So we have to check if the prefix sum is actually equal to 7. For example, 3, is it equal to 7? No, it's not equal to 7. 7, the next element 7 is equal to 7. Yes, it is equal to 7. 14 is not equal to 7, and we keep on checking whether the prefix sum element is equal to the k value. Okay, and then each time it is equal to the k value, then we have to take necessary conditions. So we just start with count is equal to 0 initially, and then we keep on incrementing as we find arrays inside inside our main array. As we find sub arrays inside our main array. So if they're equal, we have to update the count. So we have to check if it's equal actually basically. So the count will go from 0 to 1, 1 to 2, 2 to 3, and keeps on going like that. Over here we see that our count will be coming as the answer over here. So we have to check if there are basically two things that we have to do. One is we have to check whether a prefix sum is actually equal to k. If it is not equal to k, means what we have to do is, if it is equal to k, we have to increment the count, right? But if it's not equal to k, there's something called sum and count that I did. We are basically finding the cumulative sum, okay? So if 7 is equal to 7, then we can just increment our count. This is a prefix sum is actually basically an array. So what we are doing here is cut sum minus k is equal to value. So we need to find cut sum minus k. Okay, so how are we going to do that? By using a hash map. By, for example, if the hash map is my map, you have to find whether cut sum minus k is actually present. So what is cut sum over here? That is the current sum. So k will be the k is the sum of the digits, which is 7. So we need to calculate if it is not equal, right? For example, over here, 14 is not equal to 7. So once we have checked for that condition, next if condition, we have to check whether 14 minus what is that, k? Okay, cursor minus k. 14 minus 7, is that equal? Is that can we find 7 earlier in the hash map? So if we actually find 7, then we will increment that count. Okay. So it keeps on going like that. If we see our this sum and count, our hash map, so we see that 3 is there. So we'll just keep our count as 1. Then we encounter 7, that will be 1. Then for 14 that will be 1. But then we are encountering 14 again over here, right? There are two. We are encountering 14 twice over here. So the second time when we encounter 14, our count will become not 1, but it will just become 2, because we are encountering twice. Earlier we encountered 14 once, and then again over here we are encountering the sum as 14. So we have to do it to we'll just increment it and becomes 2. Similarly for all the rest of the sums, we have to keep on finding its count. So if we just implement it in our code, we can see that inside this we will just start with our code. So here we'll just use if we'll start with int n is equal to nums dot size. So we're just going to find our size actually, and then we just store it in the variable n. So if we see that if the size is actually equal to 0, then we cannot do anything and we'll just have to return 0. So this is like a boundary case. So if it is equal to 0, we can't do anything. Then we are going to use an unordered map for this, unordered underscore map, and that map will be containing 2 integers. Okay, so int comma int, and then we'll just name it as my map, right? So that key will be prefix sum basically, and the value it's a key value pair. So value will be count of the prefix sum. So we'll just keep 3 variables, that is current sum. Our current sum will be equal to 0. Then int I is equal to 0. Then int count will be also equal to 0 first. Both everything will be equal to 0. Then we are going to enter inside our while loop. So while I is less than n, so it only iterates until the end of the string, end of the array. I'm very sorry. So cur sum will be that current sum which I was talking about. That will be okay. So we just keep on adding it. Nums of I, cur sum will be nums of I plus the previous cur sum. So after that, we're just going to check if actually our cur sum is actually equal to our k, right? Whatever the k has been given, if that is actually equal, then what we can do is we can just increment our count. That is equal to 1. Else if it's not, if it's not equal, means you have to check in our map, right? We want to check inside our integer to integer mappings, and we want to check if it is actually found or not. What are we going to find? Custom minus k, right? That means we're going to subtract it. Like for example, 17 for 14 minus 7 we did it earlier, and 14 minus 7 is 7, which is actually present inside our map. But if it's not equal, it's not equal to my map dot end of. Then what we do is we will just we are going to uh, increment our count of that specific thing. Okay, not of everything, just of that specific cursor minus k value. So that will be cursor minus k. So after that we need to perform some basic operations that is not inside any of the if conditions. So it will just be outside the both of the if conditions. That will be IMAP, we have to keep adding also, right? Otherwise, how we cannot calculate it. So that'll be car sum, then plus is equal to 1. So we'll add it, and then we will just increment our I value as well. After we incremented both of it, and then we exit out of our while loop, then finally what we have to do is we need to return something very important. Otherwise, our program won't work. That is count. So have we done everything correctly? Yes. Let's just run our code. Okay, there's an error over here. Okay, it should be capital because it is case sensitive, and is equal to k. Okay. Should be very careful with variables, otherwise it'll just mess up your program. Yes, so it works now. Thank you.